and you draw a line, a vertical line perpendicular to the XY plane, and you map your point A, the projection of A, capital A, on the horizontal plane.
Sort of make it 1 minute behind, like back, so that students will recall it.
An auxiliary vertical plane, in the sense that the height of point A from the horizontal plane as projected in any vertical plane has to be same. In other words, what I'm trying to say is your OA dash and O1 A1 dash distance has to be same. Both represent the height of point A above the horizontal. Now just also look at the notations carefully. You know notation A is on your horizontal plane and A dash vertical plane. But because now we're talking about the auxiliary vertical plane, okay, the A dash now becomes A1 dash. Why 1? Because this is a first auxiliary plane. Suppose you have multiple auxiliary planes, you may call it as A1 dash, A2 dash, A3 dash. That's a convenience in case you have multiple planes. So how do we draw the projections of the point A on the auxiliary vertical plane? First, let us do the normal vertical plane. So we draw your line XY, and you draw a line, a vertical line perpendicular to the XY plane, and you map your point A, the projection of A, capital A, on the horizontal plane is a distance OA, and because it will be given that point A is so much distance from the vertical plane represented by XY line here. So you draw the line OA as a distance of A from the vertical plane. Similarly, what you do on the other projection, vertical projection, you say that the point A is so much distance from the horizontal plane, and horizontal plane is represented by the line XY here. So the OA dash represents the distance of point A from the horizontal plane. These two are able to do. Now remember the point. What did we say? We said that this OA dash has to be same as O1 A1 dash. Okay. So we now draw this auxiliary vertical plane. If you see auxiliary vertical plane, if you see from the top view projection of that, the AVP projection on the horizontal plane is now represented by X1, Y1. Again, why X1, Y1? Because the first auxiliary vertical plane. If you draw one more auxiliary vertical plane at an angle is of alpha or some other alpha 2, then that will be called as X2, Y2, and so on. So that's convenience for representing multiple planes. So let's get back. So you're now drawing the AVP at an angle of alpha to your XY line. Okay, now we have X1, Y1. And now from the point A, which is projection of point capital A on the horizontal plane, from the small a, you draw a line which is perpendicular to X1, Y1. Keep extending that, and then measure off a distance O1, A1 dash, which is same as OA1. Why? Because OA1 is this one on the vertical plane, and O1, A1 dash is now this point on the auxiliary vertical plane. Just look at auxiliary vertical plane is we have just flattened it. If you just put it back again on the horizontal plane, it will just, that is O1, A1 dash for you. Just visualize it. On the right side, which you see is the same thing, but drawn without the planes. You know, here we are presenting the vertical being horizontal plane. You don't have to do that. Simply draw X1 line, XY line, put a point O, draw a line through the point O, perpendicular to the line XY, and then mark your OA and OA dash depending on the distance of point O from the vertical plane and horizontal plane respectively, what I just told you, right? And then you, from the point A, you draw a line, before that, you draw your line X1, Y1, because we are now drawing the auxiliary vertical plane at an angle alpha, right? Draw the line X1, Y1. To that line, you draw a perpendicular line from A, which goes all the way. Just keep projecting that. But then you identify the point A1 dash as O1 A1 dash, which is same as OA1 in this, and therefore you get your auxiliary vertical plane projection of point A. That is for your projection on auxiliary vertical plane. Now I'll just pause for a second and let you figure out how to do that on a auxiliary inclined plane. Okay, and let's give you little hints. So auxiliary inclined plane is your this plane, right? And that plane projected onto the vertical plane is now x1 y1 line, which you see here, x1 y1 line on the screen. Okay, and you just reverse the whole thing. The what rule to remember here? Because in the previous one we said height is common. In inclined plane, the depth is common, which means the depth of the point P. Okay, the depth of the point P, which is a projected point P is small p, and on inclined plane projection will be P1. So your OP and O1 P1, the depth, which is the depth of the point P from the vertical plane, will always be the same. So did you figure out how to draw this? So same way, we now jump to the right side completely because now you don't need the middle figure help. Let's see if we can directly figure it out. So you draw your line XY, pick some point O on the line, draw a line perpendicular to that, which is, and then mark your point P and P dash, depending on the distance of point P from the vertical plane and the horizontal plane. Okay, and then now you're trying to draw your auxiliary inclined plane. That plane is, remember, now inclined to the horizontal. So let's say angle beta. So now you draw your line x1 y1, which is at an angle beta to your x1 line, and on that projected line you draw a perpendicular from P1. Okay, and now what will be equal? Your depth is equal, so your OP will be equal to your O1 P1. That's how we define the point P1, which is the projection of the point P on the auxiliary plane. Okay. All right. Now we will go a little bit. Okay. This is a relaxation exercise. Okay. I'm just putting a auxiliary plane. Let's call it as auxiliary. I mean, it happens to be perpendicular to both the planes. And if you remember in the beginning, I said there are three principal planes, right? And the third principal plane is called a profile plane. But let us treat profile plane as a special case of an auxiliary plane, just for fun. Okay? And you can call it as a profile plane, which is at 90 degrees to the horizontal plane. In other words, it's a inclined horizontal plane. So what will you do now? Same as previous case. Just remember this case. Auxiliary inclined plane, which is at angle beta, okay, to the horizontal. Except now beta has become now 90 degrees. So your y1, which is on the top, remains in the same place. This x1 now comes in the place of y here, because we are now turning it to complete 90 degrees. So now watch. So my xy is same. Okay, now, and this becomes my x1 y1, which is my auxiliary inclined plane. Okay, inclined plane, inclined at 90 degrees to horizontal. So what do I do? So this line, so I draw this line. XY line is drawn first. I pick some point, and I can draw the line x1 y1 through that. The original point O is where you're projecting the A1, A and A dash, distance from the vertical plane OA, and distance from the horizontal plane OA dash. That is already done. So you have already marked the point A and A dash. Now you want to look at the projection of the point A on the profile plane, which is auxiliary inclined plane at 90 degrees. So what do? You draw a line A dash through O1 dash, project it, and mark the point A1 so that O1 A1 is equal to OA. And so this point A1, which you get in this view, in this way, becomes your projection of the point capital A on the what is called as the profile plane, which is 90 degrees. Okay, and this view which we get like this on a profile plane, which is 90 degree auxiliary inclined view, is nothing but what is called as a traditionally side view. Okay, And so this is also a good way to introduce the side view file for you. So at this point, I'll take a pause. In case of multiple questions now or doubts, we'll clear that and then we'll go on.
Okay. So now we'll take the doubts. If you are having any doubts, you can start. Devant, you can share your PPT so that students are having any doubt, they will ask it.
Yes, yes, yes. Is my screen
Yes.
visible?
Yeah, it's visible. Somebody, Pal Agarwal. So you want to ask some doubt, you can go ahead.
Yes.
After that, Kandar. Yeah.
Yes. Yeah, I had a doubt like when we draw, can you go to the previous slide? Sure. Any of the either the auxiliary, yeah. So for the example, this one, so we would be given this x1 point, like the distance of this x1 point from O, from where we have to draw this another plane, right?
X1 and X1, Y1, there is no particular distance.
Devant, your voice is very low.
Okay, okay, okay. So there is no particular point, fixed point for X1. It can be anywhere on that whole line X1, Y1. You can see on the rightmost figure, the X1, Y1 line. So it's the whole plane. So we have in 3D coordinates x-axis, y-axis, z-axis, and we have xz plane, xy plane, yz plane. So it is something like that. We need not keep our designation at a particular place. It can be anywhere on the whole line, right? So this
Uh,
is something like that.
no, but like my doubt is that in the 3D view, like the first figure which is shown, so
Okay.
this auxiliary inclined plane, the position at which it is intersecting the xy line, it is x1, and there can be similar planes like similar parallel planes which can be starting at the point x and all along, like they can lie anywhere in this xy line. So is it like this angle, this beta angle is a property, like we have to use it to make the figure. So similarly, is this point x1, is that also a property which we have to keep in mind, or we'll just be given the angle and we can take any point x1 on this line and we can draw that projection?
Yes, that's what I said. No, it's you can take it anywhere on the whole plane in the whole plane.
Okay, okay. So
You
their
there
relative,
is no
their
fixed
relative.
there is no fixed place for you to keep x1 at only this point. No, it's not
Okay.
not it's not like that. See here it is there on the xy line. X1 is labeled on the xy line. Here it is
Yeah,
labeled below, or sometimes it can be somewhere here also,
yeah,
or
yeah,
it
yeah.
can be here also. It can be
Hmm.
on the left side also. So is
Hmm.
the key property is this beta.
Okay, okay. So like, okay, so the x1, y1 which is shown here in the right, in the rightmost figure. So we can draw it on the left side of this PP dash also. It would be.
Yes, you can take that side also. We'll
Okay,
see
okay.
we'll see in the following slides where you can keep it according to our convenience. We can place our x1 y1.
Okay, okay.
Yeah,
Okay,
we'll
We'll
fine.
see
move
that.
ahead. Kandar, you have some doubt, you can go ahead now.
Yes, like in this or the earlier figure, how did we project this auxiliary plane into the two-dimension thing like as we did for vertical plane and horizontal plane? Can you explain?
Yeah. Okay. So this is pretty clear. The vertical plane, horizontal plane, right?
Yes.
Now there is this auxiliary inclined plane AIP. So this is also clear for everyone. Now what happens is when you are taking your projections, front view, top view, what do? You see from this side to get the front view. So similarly, when you see this whole plane from this side, then what will happen? If you see from this side, what do you see? So this whole plane, you see it as a line.
Yes.
Yeah. So that line is our x1, y1 here, x1, y1. And coming to how did we get this part of the plane? That's what your question, right?
Yes, yes.
Yes. So now what happens is now that we have projected P to AIP and we named it as P1. Everyone understood why it is named as P1 instead of P1 dash or P, right?
Yes.
Yeah.
And
Right.
Revant, I think there is one typo error also. This is AIP, not AVP, right? So in the first line, top it is written AVP is perpendicular to VP. Basically, it is AIP, auxiliary inclined plane, which is
Yes,
perpendicular to
yes.
VP.
Yes,
Yeah,
this is a typo, yeah.
yeah. So for students, don't get confused. This is AIP, okay, which is perpendicular to VP and inclined to HP. Okay.
Yeah.
Sorry, Kanta, you can. Sorry, Revant, you can go ahead. Yeah.
Yeah. So yes. So now we have got our x1, y1. Now the key point here is everyone know how we are converting this VP, HP to perpendicular planes into our 2D figure. We are rotating our horizontal plane about the line XY. We are rotating this plane in this direction. If you see from this direction, X from point X, you observe that the plane HP is rotated 90 degrees in clockwise direction. In the similar fashion, what do we do is, uh, about the line x1, y1, we rotate this AIP, auxiliary inclined plane, 90 degrees. So then what happens? This plane will also coincide with VP, with the plane of our page. We can say with the plane of your page. So then what happens? Since you have already projected P to P1, you know what is this O1 P1, right? You know what is this O1 P1. So when you rotate this plane, whole AIP plane about the line x1, y1, you this part x1, y1. So now what do you do is, now you have rotated it. There is no need for you to represent it in a box or something like that. So that's the reason what do we do is we remove all these lines, additional lines, whatever are there. That's what we do in projecting everywhere, everything. So that is what we do. We get it on the rightmost part, rightmost figure of the projections and all.
Yes, got it. Clear. Thank you.
Samiksha, you
Uh,
have
so,
some doubts?
Sorry to interrupt. So, can you just go to the previous slide so that we can have a similar explanation for the AVP, just
Yeah,
to see
yeah.
how it gets
Okay,
here?
yes. Never mind. We'll take it up. So see. Now this is the same case. So now what happens is you see these planes from this direction. Because then what will happen when you see from this direction, you get x1, y1 here. You get the whole plane projection of AVP is brought down to x1, y1. So now what happens is, in the same fashion how we rotate HP in clockwise direction when seen from X about 90 degrees, we rotate the same AVP about the line X1, Y1 from point Y1. Why Y1? Why not X1? Why? Because one thing is you should always be outside the figure. So whenever you have a figure like this, you either see it from like you should see from the outside. So one outside, one extreme is this side, one extreme is this side. You might say y is also an outside point, but can you even imagine being behind the figure and seeing the figure? It's just complicating things. When it is visible for you pretty much clearly from these two sides, we don't want to imagine ourselves being at point y and rotating the things and making our life complicated. So it's all very simple. Make your life simple, that's all. So you just rotate from x for vp and hp. Similarly here also you rotate from y1 the same in clockwise direction 90 degrees. So then what happens? This whole plane will be coinciding with this plane. So now we just remove all the external lines and all, and we get the 2D projections of point. Understood?
Yes. Okay,
Yes.
thank you.
And one more thing is, you need not get confused what we need to label as x1 y x1, or if you take one more plane, what we need to label as x1, what we need to label as x2 y2. You just go in flow, that's all. The initial line is xy. So if you take another auxiliary plane, be it auxiliary inclined plane or be it auxiliary vertical plane, you just label it as x1 y1. And if ever you wanted to take another projection, which we'll see further, then label them as x2 y2, that's all. But these labelings are important. If you are projecting onto auxiliary vertical plane, it should be labeled as a1 dash, and y dash because it is called as auxiliary front view. And we already know front view should be labeled as a lowercase alphabet with a dash, and top view is labeled as a lowercase alphabet. So that is what we are doing. This is also the front view, but it's only that it is an auxiliary front view. That's why we label it as a1 dash. Whereas if you go to auxiliary inclined plane, this is the auxiliary top view. That's why we label it as just lowercase. So since we have already used a P1, I mean P, small p, we don't want to get confused. That's why we use P1. If in case you wanted another auxiliary top view on another auxiliary inclined plane, you label it as P2. So these notations are to be noted. Front view is with dash and top view is without dash. And you can just go on with the increments P, P1, P2, P3, like that. So any more doubts?
Samiksha, Samiksha, you can go ahead if you
Yeah.
have.
Yeah, so can you go? Yeah, this is the slide. Okay, so
Yeah.
I had a doubt. Like we are given with P and P dash, and we are given with beta. So you have to
Yes.
construct the rest part of this figure. Then how do I go about it? Like, should I take any point x1 on the line xy and then draw an angle of beta and then connect it with y1, or how is it? How do we do that?
No, it's nothing like connecting with y1. This whole plane x1, y1, you develop it at once.
Okay.
Don't take that this is this is an intersection point. This is y1. No, so this is the final figure. You should only observe this one. The job is to create the auxiliary plane. So this is the auxiliary plane. I've already said it can be on the right of P dash. It can be on the left of P dash. Okay.
Yeah.
Or it can see here we have x1 y1 at this point. There is a chance that you can have x1 y1 here also. Maybe this is x1 y1.
Yeah.
Maybe this is x1 y1. Okay. The
Yeah.
angle beta is important.
Okay, so it should maintain the angle beta.
Yes.
Okay.
Tejaswini, you have some doubt?
Uh, yeah. So in which direction we rotate the x1 y1 plane?
So you see from this side, it's there is an arrow already here. You see from this side, there is you get the x1 y1. Now you rotate from this line. Rotate about this line x1 y1 from point x1. You just rotate it like this. Are you getting?
Um, Means previously we were doing like horizontal plane was rotating in clockwise direction, right?
Yes. This is also the same way. About point, you see from this side here. You just rotate this point, rotate this plane in this direction. So it's
Okay.
clockwise only.
Okay.
See, you can rotate it on the other side also. There is no hard and fast rule key. You should rotate only this side. But, can you just imagine what will happen if we rotate this side? Just imagine this whole
Uh,
diagram. This whole diagram, you will get it here. Isn't it making our life complicated? Isn't it
yeah,
making the diagram complicated?
yeah, got it.
Ah, it's as simple as that. Just keep the things clear. That's all. That's why you are
And also
given
the
marks for neatness in engineering drawing. Yeah, go ahead. You're
uh,
asking something.
huh, and also the x1 y1 plane should be perpendicular to a vertical plane, so that we are
Yes, that's
maintaining 90
because
degree. Huh.
yes, that's because this is an auxiliary inclined plane.
Hmm.
Yeah, so this will be auxiliary inclined plane means it is inclined with the horizontal plane. So that
Hmm.
means that it should be perpendicular to vertical plane.
Hmm. Got
Yeah.
it.
Devant, yeah,
Any
can
more?
you
Any
can go
more?
ahead.
Yeah. So I guess everyone understood this diagram. This is color coded also. If you have any doubts what dimension is to be taken, then you can always refer this diagram. So this is we have spoken that this is the height of the point and this is the breadth or width of the point. So when you take this point projection onto an auxiliary plane, when you extend from A dash, you should take the measurement of breadth or width. And when you extend from A, everyone knows the side angle projection. So I'll just so this is the projection, right? This is how we project things. This is a meter line, and this is how we project. Yeah. Okay. So when we are drawing the projection from A, that is top view, you should take the dimension which you are getting in front view. Which you are when you are drawing the projection from A dash, that is front view, you should take the measurement that you have obtained in top view. So the output from here is both A dash and A are important for us to get a projection on an auxiliary plane. That is an important output from this. So okay, we'll go ahead. Yeah. So since we have seen what is projection of a point, now we'll take up what is projection of a line. So we know that the project line is nothing but a joining 2 points. So here we have 2 points A and B. Now we wanted to project this onto an auxiliary vertical plane. So this is our aim problem. So now how do we take this up? One more thing is, why do we need to draw an auxiliary view first of all? So here what do we do is, we wanted to get what are the actual angles of the what are the actual angles the line is making with respect to horizontal plane or vertical plane, or what is the actual length of the line. These are some of the objectives which we can't get from only front view and top view. We'll see that example. So I just wanted to tell that why are we using this auxiliary plane first of all. So that's why I brought it up. So now we will see how this line AB is projected onto an auxiliary vertical plane. So now we have an angle phi with which the auxiliary vertical plane is there first of all. So this angle will be given phi. So depending on that, we have to get the projection of the line, auxiliary projection of the line. So it's simple. We get A dash B dash and AB in the very first step, right? Since these are the one is the top view, one is the front view A dash B dash, and one is the top view AB. Okay. Now we draw. What is our next step? Our next step is to draw the auxiliary plane. So what we have we discussed? Its auxiliary plane is nothing but where is the pointer gone? Yes. Yeah. So after getting front view and top view, our aim is to get the auxiliary plane. First step is to get the auxiliary plane. So this is the auxiliary plane x1 y1. How do we get this auxiliary plane x1 y1? The angle phi will be given. So our job is to draw a straight line which makes an angle phi with x, y. So you might have a doubt. Should it be in this direction, or can't I draw in this direction with angle phi here? Isn't it? So what happens if we draw in this side? We'll see that also. Okay. So let us finish this first. So we have drawn the auxiliary plane x1 y1. So remember that we just draw a single line and we are saying that it is a plane. Why? We have already seen why is that. Because when you see from this direction, then this whole plane is nothing but the projection x1 y1. So that's why we call this x1 y1 as the auxiliary plane. Okay. Now what do we do is we extend from A in perpendicular to x1 y1. We extend from B perpendicular to x1 y1. These are the projections. Projections or extend projections. So now what do we do is we draw the extension lines for these projections, and we get this O1 A1 dash, O2 B1 dash. So what are the measurements of O1 A1 dash and O2 B1 dash? We have already seen. I have said the key points. What is that? When you draw an extension from the top view, you have to take the measurement of front view. So O A dash is nothing but O1 A1 dash. It is written here. And the same similar goes to this. This point is not labeled. Okay, you can just take it as O. You treat this also as O only. So this, what is this? O B dash is O2 B1 dash. So now that we've got A1 dash and B1 dash, we can join these 2 points with a straight line, and we say that this is the auxiliary projection of line AB. Okay. Okay. Now this is the projection. Anyone have any doubt regarding this? Can I suppose no one has any have a doubt to obtain the auxiliary projection of a line? Okay, this line is parallel to HP. We'll see another example which is parallel to VP also. Okay, all right. So I think there are no doubts. We'll see what will happen if we taken the auxiliary plane like this, and this is phi, right? Then now what? How we get the projections? Let us see. So our first task is to draw the perpendicular from point A to this line, our auxiliary plane. So this is one of the line, and what will be another perpendicular? This might be another line. So we extend it, we extend them, and taking these dimensions O A dash and O B dash, we mark the points. We mark the points, and then we draw the line. Oh yeah. So then we get the line something like this. So isn't this is it good? No. It's making no sense. It's not making any sense. But here, if you see here, this a1 b1 dash, a1 dash b1 dash will give us the true length. This will give the true length. Why? Because this auxiliary plane, whatever this auxiliary plane is there, it's exactly parallel to the line AB. So that's why this auxiliary projection is giving us the true length. One more thing is this angle will be phi. It's not given in the question, but these points will help you when you take up the next one. That's why I'm telling. So when you have an auxiliary plane which is of an exact angle of the line, then when you project it, you get the true length of the line. That is the reason here when you see this line AB is parallel to horizontal plane, and when you project it onto the horizontal plane, you are getting the true length here also, AB. This AB is also the true length. So whenever a line is there parallel to a plane and you project that line onto that plane, only then you will get the true length of the line. So that's the whole objective of we developing the auxiliary planes. So now we'll see another example where the line is parallel to VP. So where is the line? This is the line. Wait, it's not labeled. Let's label it. Yeah, this is B. Okay, this is the point which we are talking about. This is the second point. This is the first point A. Okay, now is the diagram clear? Okay, so now this line AB is parallel to VP. So what is preliminary stuff is when you project this onto VP, you get the true length straight away, A dash B dash. Okay, and when you project it onto HP to get the top view, you get AB. Now you can see here AB. You can see by just a glance you can say capital A and B. The original length is way too much than the top view projection, right? AB. So here this is this AB. So on one plane when you project, you get the true length. So when you project onto another plane, you will not get the true length. It will be shorter. So okay. Now we have an auxiliary inclined plane at an angle phi. So why again phi? Let us say this line AB is also making an angle phi with horizontal plane. That's why we wanted to develop the auxiliary inclined plane at an angle phi, and we want to get the true length. That's why we are developing the auxiliary projections. So I know everyone are now comfortable how to get the auxiliary projection. How do we get it? Initially we take up this x1, y1, and then we draw perpendiculars from A dash and B dash. Why are we drawing the perpendiculars from A dash and B dash? Why not from A, B? Can anyone say it? Just for me to understand that you are understanding the concept.
because
Anyone?
because plane yeah because plane is perpendicular to the vertical plane.
Yes, it's perpendicular to the vertical plane. This is the auxiliary inclined plane. That's why you are drawing projections from A dash, B dash. So here in this 3D diagram, it is pretty much clear. Why you are taking from A dash, B dash? Why not from A, B? So these are the construction lines. So A dash, B dash to O2, and then from O2 to B1. So that's why we are taking the perpendicular from A dash and B dash to x1, y1, and you end up with O1, O2. Now you extend these lines into the plane, I mean beyond the plane, and you should take the dimension from the top view. So this is the dimension, top view dimension. O dash B is nothing but O2 B1. OA is nothing but the O1 A1. You just forget this O dash here. There are some errors in it. If you get anywhere confused from our slides, you can always refer NDBUT textbook, which is pretty much clear. See, these photos are also taken from NDBUT only, so you can just if at all you are confused anywhere, then you can go ahead with NDBUT always. So I think everyone understood how to project a line which is parallel to VP onto auxiliary inclined plane. Any more doubts? I suppose there are no doubts. Good. I've said here we have taken x1 y1 here. Why can't we take here? Can anyone say? Can we take it here as I've shown here? Can this be our x1 y1? Yes or no? Can you imagine what will happen if it is there?
The diagram will become very messy, right? It will overlap all the lane.
No. Can you come again? Sorry, I was not able to hear you properly.
The diagram will become very messy if we draw x1 and y1 there.
Why? Why it will become messy?
Like because it will like intersect many lines and will not be able to properly navigate what figure is where.
It will be like this, right? Isn't it?
Yes.
Yes, sir.
And you get AB in the same fashion, similar fashion. See, this is the angle phi. Previously, when I said it will become messy, if you remember it or not, I have changed the angle phi clockwise to anti-clockwise or vice versa. Here I didn't do that. The phi is in the same direction. Here also it is in the same direction. It is just that instead of taking on the right side of our A dash B dash, I took it on the left side of A dash B dash. So you get exactly same figure. So from output, from why I am telling this is there is no compulsion that you should take only on the right side of the projections. You can take either on the right side or on the left side. Only thing is you don't take it in a different notation. See, this angle here is taken in anti-clockwise. If you take it in clockwise, then this is the plane, clockwise plane. This is phi. This is when the messy thing happens, and you don't get proper length in this on this plane. So that is the reason what we do is we always take our auxiliary plane x1 y1 parallel to one of the projections. Either it may be front view or top view. If you take the auxiliary plane, be it auxiliary inclined plane or be it auxiliary vertical plane, if you take these planes parallel to the projections a dash b dash or ab, how do you take? If it is an auxiliary inclined plane, you take it parallel to a dash b dash. If it is an auxiliary vertical plane, you take it parallel to ab. In these cases, you get a very beautiful picture, very simple picture. If we, instead of taking parallel, instead of taking like this, if you take something like this intersecting, then you don't get a nice picture. So then you end up with a wrong answer. Okay, it is as simple as that.
Yeah,
Try
Revan,
to,
we can move ahead. But we have 15 minutes left.
yes,
And
yes, yeah. So it's like that. So yeah, now this is our main line. Why we wanted to take up auxiliary planes, we'll discuss here. So here we have a line which is inclined to both HP and VP. So this is the line AB, capital A, capital B, which is inclined to both VP and HP. So when you take the projections of this line, when you take the front view, you get this projection. And when you take the top view, you get this projection. So this is where we represent our front view and top view. We have already discussed why alpha, beta, why not theta, phi. I have illustrated with a scale. What can alpha be and what is beta? I think everyone have no doubt about it. Okay. Now let us see. Yes. So this is one of the key feature. This is also discussed in the previous class. The true length is the maximum length of of a projection can be. So since the line is at an angle with HP and VP, when you project it, what happens? It will shrink. So the top view and front view, both the views will not give you the true length of the line AB. So for this, what do we want to do is we want to develop a auxiliary view. So we'll see which auxiliary view will give us the true length. So this is just what I've spoken about. Okay. Now let us take a auxiliary vertical plane. Now I think everyone are pretty sure. As soon as I say auxiliary vertical plane, it should be perpendicular to HP and it should be at certain angle to VP. Right. So this highlighted black one is the auxiliary vertical plane we are seeing. Okay. Now we wanted to take the projections. We'll see why only this is the auxiliary vertical plane. Why not with some other angle and all? Okay. Okay. So what we have discussed, if we have an auxiliary vertical plane, we'll take this auxiliary plane, we'll draw the auxiliary plane parallel to line AB. I've said why we need to take parallel also. Okay. So take this parallel to AB. So what is the angle of the auxiliary plane? It will be beta, right? I think everyone understands why it is beta. These two lines are parallel, and so xy is this one only xy. So this is the angle which is same as beta. Okay. Now since that we have the auxiliary plane, we need to get the auxiliary projection. So how do we get the auxiliary projection? We draw the perpendiculars from the endpoints and we extend them. So these are the extensions. And now what we do is this dimension is nothing but this dimension we take from the other view. What is the other view? Since this is the top view, this will be the front view. So this is the dimension D1. So this D1 is the same D1 here. So when you draw the perpendicular and you extend, you have to extend to D1 and mark that point as A1. Why A1? Because we are extending from A. So now you have to start from B. You have drawn a perpendicular, you have extended it. How far you should extend this? You should extend this of about this length. What is this length? Now it is D2. Now you have to dimension D2 and mark this point as B1 dash. Now when you join these points A1, sorry, it's not Yeah, it's the dash only. Here there is no complement. When you join this A1 dash and B1 dash, now you get the true length of the line AB. So now let us see why it is the true length. We have we have got the auxiliary projection. Why are we calling it as true length? It may be that it is also short. So we will see that why. When you have the auxiliary plane parallel to parallel to the projection, what happens? Uh, it becomes parallel to the line AB also. This line AB, it is projected here. You can see it is projected here. Now we are taking this plane which is parallel to this projection. So we'll just go back here. I'll just show you. See, so this line AB is parallel to VP. Now when you take a plane which is at a same angle phi as that of the line, this line AB, when you take up that auxiliary plane, you get the true length when it is projected. That projection will give you the true length. We are doing the same thing here. We are taking the auxiliary plane parallel to one of the projection. So this is the top view. We are taking the auxiliary vertical plane parallel to top view, and we are projecting our AB onto that auxiliary plane. So we end up with the true length of the line. So this is one of the auxiliary plane, auxiliary vertical plane. So what if we take auxiliary inclined plane? This is the auxiliary inclined plane. So now that I've explained auxiliary vertical plane, this is also very simple. You have to take auxiliary inclined plane parallel to the front view. So this is the front view. Now we take the auxiliary plane which is parallel to this projection. And this is the extension line. This is the extension line. And you take the dimension from the top view D3 and D4, and you mark it on the auxiliary planes D3, D4, and you get the points A1, B1, and you join them, you get the true length of the line on auxiliary top view, in auxiliary top view. I hope these both things are clear. I've gone much more faster because I have given a lot of time why it is so, why it is happening and all. Now, any more doubts?
So like we can find the true angle by either way, like by using either of the planes, and just to find theta and phi, we have to do the respective projections. We'll have to draw.
Yes, yes, yes. I've already said in the previous class what are these phi, alpha, beta, and theta. Here there is theta. This is the true angle of the line AB with respect to what will it be? With respect to HP. With respect to HP, yes. Okay. Theta. What is phi? It will be the true angle of the line AB. It will be the true angle of the line AB with respect to VP. This is that angle. So wherever you have true length, you get the true angle also. Okay. So any more doubts?
We can move ahead. We can move ahead.
Yes. Yes. So yeah. So that's it. Now what? Now we'll see what are some more uses we are having from auxiliary plane method and all. So when you wanted to find the shortest distance, what do you do? When you want to find the shortest distance, you just draw a line perpendicular from that point to the line, and then you say this is the shortest distance. For example, let me put this in other way around. What is the shortest distance from our origin to any line in XY plane? You draw a perpendicular line from origin to the line, and you measure it, and you give it as a shortest distance. That is in a 2D. So what if we ask it in a 3D? So in 3D also what happens is the shortest distance is always the perpendicular distance. So here, when it is asked what is the shortest distance between a line and XY line. So what is the XY line? When you see from one side of this line, then you can see the whole XY line as a single point, isn't it? So from that point you can measure the line straight away. So that is what we do here. We project the whole thing so that we convert this XY line into a point O. Since we are, when you are watching from one view, one side, one angle, you have to watch everything in that aspect only, in that perspective only. So that's why what do we do is when you are projecting this whole XY line as a point O, you have to project A dash B dash also. So this is it. When you project A dash B dash also accordingly, then you get this line A1 B1. So what is this? This is nothing but the left side view, isn't it? Since you are watching from the left side, you project this XY as point O. When you watch this line A dash, when you watch the line from the left side, you get the left side view A1 B1. Now this is the shortest distance you get. So everyone understood this? How do we get the shortest distance between a line and an XY line? Any more doubts in
How
this?
did we locate A1 and B1?
It is the left side view. Here actually the constructions are not proper. I'll do the constructions here right away.
Oh yeah, I got it. Huh.
You have already did this. You have already constructed the right side views and left side views. Okay.
Yeah.
Actually not so appropriate. Then I'll just try to make it appropriate as far as possible. So I think
How will we define where the O will be like origin?
yes. It's see yeah. Can you tell me? See, there are we have three coordinates x, y, z. Huh. So x, y, z. So when you look it in a 2D direction, where is z axis? Just imagine you have the 3D coordinate axis x, y, z, and you took the projections and you brought the 3D onto 2D x, y. Now where is z axis? It is at the origin, right? You are looking xy axis means what does that mean? You are looking right in the angle of z axis only. So you get where is z axis? It is at the origin point. So this is also in the same way. When you look from this side, what happens? This xy will project to origin. So this is the origin we have. Okay. And when we project this a dash b dash to a side view, we get this.
Excuse me.
Yeah.
Sorry, but us math students actually have a class that a
Yeah.
rescheduled class that's actually at 11. So
Yeah, sure.
we're actually gonna have to leave now. So
We'll
like,
stop
if
it
you
right
don't
now.
mind,
Yeah.
could you just mark our attendance as we're leaving, so that our attendance is
Yeah.
counted, assuming you guys are continuing.
Yeah, it's okay. So Revant, have you finished this projection of line and how to find the
Yes, yes,
shortest,
projection of line and a point is done.
how to find the shortest
We
distance
just
that
have,
that covered? Yeah.
I'll just give a gist of one more thing.
Yeah. Just
So
within 2 minutes
what
we
is
can finish it. Yeah.
just 1 minute, that's all, we'll leave. So right now I've told you how we get a shortest distance between XY line and any other line. So how do you get a shortest distance between a point and any other line? It is nothing but the perpendicular distance from that point to the line AB, right? So that is our next concept. This is the point, and we, sorry, hello,
Nothing. Go ahead. Go ahead.
yeah. So that is how we get the shortest distance between the point and the line. So when you bring up the projections onto HP and VP, it is difficult to imagine where exactly the point is and where exactly the whole line AB is. That's why what do we do is, using these auxiliary planes and projections, we try to convert the line AB as a point AB. This is the point AB. And accordingly, the point P is also projected, and then we'll measure the shortest distance. So just give a thought how the whole line projection, how the whole line AB is converted into a point. I'm telling you to give a thought because you already know how a whole line XY is converted into a point O. In the similar fashion, this will also be done. So just give a thought how will it be done. So from here we'll take it up in the next class.
Yeah. So the next lab session will be uh, till this the projection of line and how to find the shortest distance between line and the point. So yeah. So now we are closing this session. We'll continue from this one onwards.
Yeah.
Thank you.
Thank you everyone. Yeah.
So if there are any more doubts for anybody and you don't have the class, you can ask. You can go ahead.